Welcome back to Metabolism Wallah NEET. Today we will learn the tricks to remember all orders of electron gain enthalpy and electronegativity. So this is trick number 5 in organic chemistry tricks that will blow your mind. So let's start. Electron gain enthalpy is the energy released by an isolated gaseous atom while accepting an electron. We all know this. Now, sometimes energy is also absorbed when electron is accepted in atoms which have stable configurations. We will always take the energy's negative value. If energy is absorbed, then we will call it positive energy, and if energy is released, then it is the negative energy. But in the negative energy, we will only take the positive value, and in the positive energy, we will take its negative value like this. We will take the positive value for energy released, and we will add a negative sign before the energies when the energy absorbed. So energy is absorbed in S2, P3 and P6 configuration because these are stable. P6 actually means S2, P6. So it is the most stable. This is more stable, and this is also stable, but the least among all these three. But S2 configuration, when it is helium, it's the most stable among all the elements of the periodic table. Okay, more energy, done. Okay, understood. The largest energy is absorbed in fully filled P, that is P6 configuration, means S2 P6 configuration. Okay, and electron affinity decreases down the group and increases across a period. We all know this, and both of them are irregular. Okay, and if we compare the electron affinity of second and third period, the electron affinity of second period is always less than third period because the small sizes of the atom in second period, so the electron has difficulty in entering the small electron cloud. Okay, next, fast electron gain enthalpy. In period 2, we can see lithium has 2s1 configuration, beryllium has s2, boron has s2p1, carbon has s2p2, nitrogen has s2p3, oxygen has s2p4, fluorine has s2p5, and neon has s2p6. Now among these, neon, nitrogen and boron are stable, and among these also neon is the most stable, nitrogen is the stable, and beryllium is more stable than nitrogen. Okay, so we will first write the most stable one. Here you can see most stable one, and then the more stable one, beryllium, and then the stable one. Okay, and then we will write the rest of the elements in the order of their arrangement in the periodic table. Okay, what is that? That is the order of atomic number. Okay, now we will put the signs like this. We know fluorine has the highest electron gain enthalpy, so fluorine will be the largest and neon will be the least. Okay, moving on. Now for second electron gain enthalpy, we will add one negative sign after all this and add one electron in the orbitals. This is wrong actually. Here will be 2s2 2p1. Okay, now 2s2 configuration is very stable, and then 2s2 2p3 configuration is stable, and then 2s2 2p6 configuration is stable. So we'll write like this. Okay, so this is more stable, this is stable, and this is the most stable. So we'll first write the most stable one, then write the more stable one, and then write the stable one, and then in order of their atomic number. And if you notice, here I have put neon. Neon will be at this back because electron gain enthalpy decreases down the group, and this configuration is of potassium. Potassium has very less electron gain enthalpy. Okay, so the order will be like this, you know, Ne minus, then F minus, then Li minus, then C minus, then Be minus, then boron minus, then nitrogen minus, and then the greatest will be oxygen minus, and here will be 2s2 2p1. Okay, remember this, 2s2 2p1. In the third electron gain enthalpy, we will put 2 negative after all of this, and then add one electron each. Okay, like this. Now this is stable, this one is stable, this one is stable, and this one is stable. You can see this. But because of this is in the next period 3, this will have the least electron gain enthalpy. Now you will comment down the order, and if it's correct, I will give you a heart. Okay, now the period 3, it will be like this. This one is stable, this one is stable, and this one is stable, and this is more stable, this is stable, and this is more stable. So we'll write first the most stable, then more stable, then stable one, and then write all of them and give the signs. Okay, thus this order is 100% similar to the previous order of first electron gain enthalpy. Okay, now if we find out the electron gain enthalpy group wise, the general trend will be period 2 greater than period 3 greater than period 4 greater than period 5. But this is not the correct one, because the elements of period 2 have small size. Okay, so we will take the period 2 over here. So we have exchanged period 3 with period 2. Now this is the general trend. Now discrepancies are in boron, oxygen, and noble gas family. Okay, in boron and oxygen and noble gas family, we will turn this period 3 will be here, the period 2 will go to the last. Okay, like this. Okay, now all these sources are NCERT group wise charts in p block families. Okay, now in carbon, nitrogen, and halogen group, we can see to make the order, we will exchange the first and second elements like this, and then put the signs. Done. And for discrepancies in boron, oxygen, and helium family, we will just take the first element, and move it to the last. Just take the first element and move to the last. Just take the first element and move to the last. Here you can see all these have positive values. Here the negative values are not taken, but here the negative values are taken. Okay, remember this. Just open the groups in P block and compare my orders with them. Okay, next for electronegativity, here we have to make graphs of these orders. Okay, the general trend is that electronegativity increases across a period, and this is without any discrepancy. Here you have to remember at least the Pauling scale. The Pauling scale gives a value of 4 to fluorine, and then it is based on comparison. For example, here you can see lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. So fluorine is 4, and we will decrease 0.5 for each. 3.5, 3, 2.5, 2, 1.5, and then 1. Okay, now trick to remember this order is to make graph of this group, like here mangan, alu, gajari, thaili. Here you can see the graph steeply decreases downward and then increases slightly. Okay, so the order will be like this: B greater than TL, greater than IN, greater than GA, greater than AL. Okay, AL is the least of them. In carbon family, we will see a graph like this. After carbon, it steeply decreases, and then it is equal up to Sn, that's tin, and then slightly increases in lead. So the order will be like this: carbon greater than lead, greater than Si, and equal to Ge and equal to Sn. In nitrogen family, it steeply decreases downward up to Sb, that is antimony, and antimony and bismuth have the same electronegativity. Okay, like this. Okay, in oxygen family, we can see the electronegativity decreases downward orderly. So the order will be like this. In fluorine family, it is also the same. In group 1 and group 2, it also decreases downward the group, like this. Okay, so the orders will be like this. There is the revision. Take a screenshot. Okay, and remember like this. Thanks for watching. Next video will be on second ionization energy.